Well, good morning, viewers. Today we have a 2009 Chevy Silverado. It's a little long in the tooth by the looks of it, and it's here because it routinely starts cutting out and apparently is sitting a P0601, I think it is. I brought it in just now, and the check engine light was on when I drove it in, but I don't see it on now. But we're going to scan it and see if there's any codes. I think the code he's told me was P0601. I see he's got the high-tech Innova code reader here. I think it's internal ROM failure or something. So this is a US truck. It's in miles. Yeah, it's in miles. 250,000 miles. So we're going to do a network scan of this thing. It's a 2011. Should auto ID. And I'll put the mileage in after. Let's do a code scan of all the controllers. P0573 field trim bank 1 cylinder. That's not the code he was giving me. And the anti-lock brake computer is complaining against the PCM. There's an ABS brake switch circuit fault. I'm sure the code he gave me was a read-only memory code. Field trim cylinder bank 1 symptom. Well, 16 controllers. Let's see what's on the OBD2 side of things. And the codes have been recently cleared because the catalyst monitor and EVOP monitor and O2 sensor monitors are not complete. No codes on the OBD2 side. Lost communication with anti-lock brakes on the transfer case. So I'm going to have a word with this customer because this is not what he mentioned to me over the text message conversation. So I checked through my text messages, and the code he mentioned to me that it was setting was P0601, which is an internal read-only memory failure code, which typically means a new or replacement ECM or PCM. So we're going to investigate this P219A. Let's go into the engine control computer and codes menu and freeze frame data. Have a look at the fuel trims when the fuel trim cylinder balance 1. Now that could be an oxygen sensor, it could be exhaust leak. With the mileage on the vehicle, anything is possible. It could be aftermarket O2 sensors. 15 kilometers since the last failure. Coolant temperature was 92, so was that operating temperature. Engine load was 58%. Short-term fuel trim and long-term fuel trim on both banks were pretty much the same. There's short-term -2, negative, and +4, -10, and -5. So bank 1 is running within specs, ±10, in my opinion, is okay. So this is inconclusive. This freeze frame data is not really helping me. Running 14 minutes and 82 kilometers an hour. So it certainly wasn't, at that instant when the code set, it wasn't rich or lean. So let's look up some cases on it. So I thought I would look in Snap-on's troubleshooter for P219A. Circuit description. The air-fuel imbalance diagnostic detects a rich or lean cylinder-to-cylinder air-fuel ratio imbalance. The diagnostic monitors pre-catalyst heated oxygen sensor signal frequency and amplitude characteristics by calculating an accumulated voltage over a predetermined sample period. An imbalance is indicated when multiple samples of the accumulated voltage are consistently higher than the desired value. Yeah, so a whole bunch of codes cannot be present. Fuel is in mass airflow. Conditions for setting. Multiple samples of the pre-catalyst HO2S accumulated voltage are consistently greater than the desired value. Very sensitive to heated oxygen sensor design. A non-OE sensor or an incorrect part number may set a false ETC. Monitoring the misfire counters, misfire graph may help to isolate cylinders. Well, this could be anything related to an aftermarket O2 sensor, a failing O2 sensor, an exhaust leak, and you know what the Chevys have for exhaust manifold bolts. Could be misfire created by a spark plug wear. So we got to have a heart-to-heart with this customer. So I moved some wires down by the left motor mount where the ground is, and the P0601 code reset. So I'm going to clean that ground and repair that ground down by there, motor mount. I'll show you where it is. So it's really hard to see, but it's right behind the power steering line there. You can see the ground cable. And I wiggled those wires, and I had the key on, and I heard a ding for the... I had cleared all the codes out of all the computers, and including the Stabilitrac control system or ABS system, and it reset a code in the engine, P0601. So that's way down there. So we got to put it up on the hoist to get at that ground. Okay. So I reached up there and pulled on these, and this one broke off. It's behind the power steering pump on the stud that holds the wiring harness. So I'm going to extend these two wires and ground them on this bolt here, I think. Don't have to be on the side of the block as long as they're grounded. So I added about 8 inches of wire to each one of those and soldered and heat shrunk them. And I moved the ground to the front of this bracket. There's like 6 bolts holding this bracket on, or 4 anyways. 1, 2, 3, 4, 5. I'm sure it's grounded. So we'll clear the code from the ECM, and hopefully that 601 code doesn't return. So we got it back together, got the key on. Display codes, D2C display, P0601. Clear codes. Yes. Now that sets a code in the ABS system too as well. I'm not sure if that's going to clear automatically. Let's check it. Okay, it cleared it automatically. Maybe it's in history. I want to double check. Yes. So let's clear that code out of the traction control and ABS system. Oops, went too far. And just double check that it's gone. Good. And we're going to start it and run it now. So I'm back in the engine control computer. Well, I'm going to take this thing for a road test now and see if it sets that 601 code. Well, there's the engine power reduced, Stabilitrac light on, check engine light on. It went about 10 kilometers. Like virtually no throttle response. Engine power reduced. Virtually no throttle response. And now it doesn't crank. Okay, let's see what we've got for codes. Good thing I brought a cell phone with me. I gotta save this recording. I really need two hands here. So I saved that recording. Let's check and see what codes we have in it. DTC display. Brake switch circuit 601 and field trim imbalance. Well, the 601 I'm worried about. It won't even crank. So let's clear the codes. Let's read the codes. Cycle the key. And it starts. So hopefully we can make it back to the shop. Well, I turned in my driveway, drove another 10 kilometers, and it stalled. And I'm rolling into the parking lot here. Engine power is reduced. I guess so. The tach is showing 500 RPM, but there's no throttle response whatsoever. No power steering. That's weird. I don't think it's actually running. Oh, that tach was showing 0. I thought this was the tach over here. That's the speedo. Well, we made it back to the shop. Turned the key off and back on, and it won't even crank. So I'm going to go back in and review the data that I recorded the last time it quit, and see if I can see any voltage dropouts. So I'm reviewing the data that I captured the first time it actually quit, and you can see that the ignition 1 signal voltage remained steady even though it had actually quit. It shut the fuel pump relay off, and it was still running at 600 RPM. Then the next frame it drops to 500, then 400, then 300. It stayed at 300 RPM for about 6 frames, and ignition 1 voltage and ignition accessory signal voltage and ignition relay command is continuously there. But it turned the fuel pump relay off and it switched it from closed loop to open loop. So I'm pretty sure that the computer is failing due to that internal read-only memory error. And the interesting thing is you have to clear the code to get it to crank again. The other code that's set was for the brake pedal switches disagreeing, and you can see when I stop the vehicle, one brake pedal switch shows that it's applied and the other one doesn't change state. So I'm sure it needs a TCC brake switch, which is underneath the dash. And we're going to get a used ECM, but before I put the used ECM in it and program it, I'm going to load test the powers and grounds one more time at the ECM with a headlight at least. So we're back working on this 2011 Silverado with the 5.3, and we're going to change this computer. I've got a previously enjoyed one here. Has to be flash programmed. But before we do that, we're going to get a pin out for the connectors here and load test the battery power, ignition power, and ground wires just before. Now I do have to have this used this original ECM in to extract the VIN. And I think I can manually enter, but it's just easier to hot swap it during the programming event. So there are 2 connectors on the ECM. It sits in there like this. The top connector is black, as you can see, and that's called connector 1, X1. It has one main ground. That large terminal in there is the ground. Pin 19 and 47 are ignition 1 voltage. So that's the second row. 19 and 20 is battery voltage. So we're going to disconnect that connector and use a headlight to load test it. So I'm using the large pin as a ground for my headlight. And 17 is this pin here. 18, 19, 20. Do not force anything in there. I'm using a 20 thou probe. I'm just touching the terminal. So you can see that it lights my headlight. Now 19 is ignition 1 voltage. So I'm going to turn the key on now and see if we got power on that terminal. Now that might come from a power relay that the ECM controls, so it may not work. Okay, so it comes from the ignition switch. And that circuit lights a headlight perfectly fine using the ECM ground. And then 47, which is the second row over, and it starts at 52, 52, 51, 50, 49, 48, 47. There's nothing in there. 52, 51, 50, 49, 48, 47. There's a terminal in there, but it doesn't light my headlight. Now that might come from a power relay. I'm going to investigate where that actually comes from. So you can see pin 73 is ground, and 47 says ignition 1 voltage, but it might come from a relay that the ECM is turning on, which obviously it can't do if it's not plugged in. And 19 and 20 check okay. 19 is ignition 1 voltage and 20 is battery positive. So we have to figure out where this 1339 circuit comes from. Just writing that down. 47. And what color is the wire? Pink black. So I'm going to pull up a schematic. So here's the color wiring diagram, the Mitchell version of the diagram. Pin 47, circuit 1339, comes from connector 1, and it says ignition 1. Then it goes on the next page here, goes across the page to location 12 by the looks of it, and comes on this page here. You can see it right here. Comes from the ECM throttle fuse 5, but that is supplied power by the powertrain control relay. So the powertrain control relay is actually turned on by the ECM. So we're going to unplug that relay and put a relay jumper in there to send power between 30 and 87 just to load test that circuit. I suppose it could be a failing powertrain relay too. They did have some issues with relays at one time, and this fuse panel is obviously a problem on these trucks as well. So this is the powertrain relay here. The terminals look good. Doesn't appear to be any significant oxidation on this. So we're going to jump with a switch 30 to 87, which should send power to that actual pin 47, which I have connected right now. I'm using a relay bypass switch, which makes it idiot proof. You can see that that circuit's sustaining a load, provided of course the relay's not failing, but I doubt it. So we're going to go ahead and reconnect this ECM and connect to GM service programming and swap it out, and then clear all the codes and go for a road test. So I've logged into GM's server and authenticated my password and bought a subscription to flash this thing, $59 US. Usually there's some kind of drama. Oh, look, a mosquito. It often looks like there's nothing happening, but you have to wait patiently, because even though I'm on Starlink, which is fairly quick, it appears nothing's happening in the background. So I had to log in again because it just seemed to be hung. Like I said, you have to wait patiently sometimes because it looks like nothing's happening, at least if they had a scroll wheel or something like that, or a progress bar. You can see there's activity going on in the background. So we finally got connected to the vehicle. 98083 is the right VIN number. Replace and reprogram. I'm using a clean battery charger on it, set at 13.6 volts. Engine control module. I believe we'll have to do a anti-theft relearn afterwards. Take up one of my VIN slots, proceed. It should tell me to swap the ECM in a minute. Okay. New software started production. Might have to check something off here. I had to pick the right programming software. There's a new calibration for diagnostic enhancements for diagnostic code P2135, and this calibration is for vehicles located in the Middle East. Well, I'm not in the Middle East, so we're going to go with this one. And operation of engine oil life monitor more accurately identify the required oil change interval. Okay, so we're going to swap out that ECM now. So it says, please confirm the ECU has been replaced. Say yes. I put dielectric grease around the seals, blew all the connectors out. This will take several minutes, so we'll pick up when we get to the end. So when I said put grease around the seals, around this area of the connectors to help slide the seals in, this is the used ECM. We're still programming. Same service number. That's the service number there, 12633-238. And we got to proceed with the same VIN. I think we got to do the theft. Later look at the theft, anti-theft. Vehicle theft deterrent. Next. Did I click it? Yeah, procedure selection. So what are we doing? Vehicle theft deterrent learn for learning replacement keys. Vehicle theft deterrent learn ECM or PK3 replace. So that's what we're doing, is PK3 replaced. Now I think this takes 12 minutes now. Used to be able to do this by cycling the key 3 times and 3 10-minute learn procedures, but I don't think you can do that anymore. Vehicle theft deterrent, start programming. I know the newer ones seem to be a little 12-minute learn procedure, but maybe it's going to tell me that here, I'm not sure. So I was right. Got to wait 12 minutes with the key in the run position. So there's the end of it. Should be capable of starting now. I'm gonna fire it up, see if it'll start. I'll move my trouble light before it falls into the cooling fan. And cycle the key off. Back on. Now I think we got to do a crankshaft variation relearn. Well, we can do that with the snap-on scanner. So we'll set that up. I got the snap-on scanner on, so we're going to do a network code clear. I can do that with SPS as well, but I find it just as easy to do with the snap-on scanner because I got to go in and view data anyways. Now we still have that brake switch to deal with. I did pick up a new brake switch on the chance that that's the problem. It usually is. Network code clear doesn't take very long. It's usually pretty quick. "16 controllers. Let's look at the engine control computer, see if we have a code for the crankshaft variation learn. Yeah, so we're going to do that. But I have to run it to operating temperature before I can do that. It has to be above a certain temperature. It's functional tests, crankshaft variation learn. Set the parking brake and lock the drive wheels. Okay, yes I did. 70. So I'm gonna exit out of here and go back in and watch data while I run it. While I'm doing that, I'll pay attention to the brake switch inputs. So while I'm letting this warm up, I'm gonna double check this brake switch. The TCC brake switch and the brake pedal position switch are one and the same. It's two switches in one assembly. And usually when it fails, one of them is disagreeing and it sets that code. Now, I asked him last night if his cruise control works, and he said no, it doesn't. So that typically disables the cruise control if the brake switches don't agree. Right now, they both, one says applied and one says released. So this one should be okay, but this one on the left side should say released as well. I'm going to step on the brake pedal. And you can see that the right one goes to applied. Now I released it, but the other one's not changing state, so it's likely the brake switch that's failed. I did have one vehicle that had an aftermarket brake controller that was causing a problem, but I don't see a brake controller in this one. One other minor issue that I just realized was I should have taken note of the engine oil life remaining on the original ECM, because I see a message on the dash that says change engine oil. So I don't know what the oil life remaining is, and there's no sticker on it. So I'm going to have to manually set that to some value based on the discussion. And maybe I'll just set it to 50% just so he doesn't have it. Functional test, output controls. You're supposed to take note of the oil life remaining before you swap the ECM, which I neglected to do. So I'm going to just set it to 50% and I'll talk to him about it. That'll get rid of the message for now. And that's reset. So let's go back into data. Engine data. And it has to be up to 70 degrees Celsius before we can do the crankshaft variation learn. And coolant temperature is 49. So we'll run it for a while I change the brake switch. Well, I'm not a happy camper. I changed that brake switch. The one on the left was not changing state, but the brake pedal position switch was changing. Now they both say released. And when I step on the brake, the TCC brake switch says applied, but the other one doesn't say released. And the brake lights won't shut off. So it appears that made in China. It appears that's defective switch. Go figure. So I called the parts guys to ask them if they had another switch, and they don't, of course. So I put the original one back in, and now they're both saying released, and it's working now. I'm stepping on the brake right now, releasing the brake, stepping on the brake, releasing the brake. So it's working again, but the new one's defective. So we're going to do that crankshaft variation relearn and go for a road test, get another switch put in there. Now this box was open when I got it, so somebody may have pulled a fast one and returned a defective switch. So I'm doing that relearn, accelerating. And that's basically it. That should clear that code. Snap the throttle right to the floor. And that code should be gone now. History. Let's clear it. Codes menu, display codes. No codes. So now we're going to record data while go for a road test. Got to put the clip on the brake pedal switch. I'm going to leave it running because, well, the longer it runs, the better. So I figured I might as well take this thing for a drive into town and get that new switch. The other one has gone back to indicating applied on the TCC all the time. As you can see, stepping on the brake, releasing the brake. So, what do we got for mileage? 532 miles. Let's take it for a road test. So I managed to get that brake switch green once. I'm on my way back from town, about 45 kilometers I've driven. The truck's running perfect. And you can see the cruise control works when the brake switch agrees. So I've gone into town to pick up a new brake switch, and I'm on my way back to the shop. So we're back from the road test. Should have went approximately 50 miles, about 80 kilometers, 75 to 80 kilometers. And the engine runs fine, no more P0601. I'd be curious whether that cylinder imbalance code returned. You can see the brake switches are agreeing now. I'm going to step on the brake. Now they're disagreeing. I got my foot off the brake. You can see this one's released and this one's applied. But if I hit it fast, I can get them to agree, released and released. And that's when the cruise control works. So I'm going to put the new switch in. But while we're here, exit out of the recorded 25,000 frames of data. Let's see if there's any codes. TTC. Yeah, that cylinder imbalance code. I'm going to talk to him about that. That's going to turn the check engine light on next drive cycle. But it could be due to the aftermarket O2 sensors that he's put in there, but I wouldn't guarantee it. So a different brand of switch, SL1000 from Napa. The other one was from another parts store, but I'm sure they're the same part, and it's doing the same thing. Notice it says applied on the brake pedal position and released on the TCC. I'm going to step on the brake, applied, released. So I'm not sure what's going on with these aftermarket switches, but I'm going to get an OEM one tomorrow. It's enough wasting time here. So I'm in Identifix looking at stop lamp switch issues. Here's a case here. Another aftermarket design issue. Replace the new aftermarket switch with an OE unit. Previously installed brake light switch was aftermarket part. Found they seem to be pretty common for having a faulty design change from the factory patent design, causing most aftermarket parts to be flawed severely. So that's pretty obvious. I got 2 defective new ones. So I'm going to get an OE one tomorrow and put it in. I'll post a follow-up if it doesn't fix it.